That's recorded for everybody to hear. I think it's only appropriate, Emily, if you respond back saying, "Don't I know you? Weren't you in my elementary school?"
She wasn't in elementary school.
No, she wasn't?
No,
Okay.
we were in the same middle school. She
Yeah, but
went
on
to Stone
record then.
Prairie. I went to Country View.
Okay.
You were in Fresno?
Okay, so,
Oh my goodness.
I shouldn't have brought that up. All right,
What was it about?
Logan, we're going to calculate the enthalpy of the reaction. So we calculated the entropy of the reaction. Let's calculate now the enthalpy. And so you know how to calculate enthalpy. We do products minus reactants. I wrote the values up here for you. So negative 1473.
So we do the same thing for entropy and entropy?
Yep. Products minus the reactants. You take the products minus the reactants, and our delta H of this reaction, this phase, is negative 470 kilojoules per mole. Is that a good thing, Ms. Binger? Based on enthalpy, is that favorable? Yeah. So if you have a negative delta H, it is favorable. So we have our enthalpy saying this reaction should occur. Okay, our enthalpy is saying barium oxide should react with sulfide. But our entropy is saying no, 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 no. Barium oxide won't react with sulfide. So who wins here, Eddie? Is entropy more powerful or is enthalpy more powerful? Well, there's a way to predict whether or not. What?
Were you asking?
Oh, that was a rhetorical question. So, don't you love it when teachers give rhetorical questions and you're not sure if they're really rhetorical?
I can never tell if teachers want us to shout out answers or raise our
Hey,
hands.
you're the only one who asks, like, says a name and then says in front of the question. Usually they'll just say,
Oh, okay. Well, anywho. J. Willard Gibbs related enthalpy and entropy together in an equation, and they named this thing after him delta G. Delta G stands for the Gibbs free energy.
Delta Gibbs.
Little factoid about J. Willard Gibbs: he was the first American to get a PhD from an American university.
Cool.
If you want to get a PhD, you used to have to go back to Europe because we didn't have the universities.
What university?
I don't know what university he got it from.
So he was the only one to graduate?
No, he went from America back to Europe to get his PhD.
so it's like TDS.
You just said he got his PhD in there.
Yeah.
I don't know where he got his PhD.
Said he went-
All I know is he left America.
So you said
Go
you were
to
the
Europe.
first one.
You just said
You
he
said
was the
you
first
were
one
the
to get it in
He was
America.
the first
because
person in
Oh,
America.
from American. That's right. I'm sorry. That's completely right. Yeah. I'm sorry. He didn't go to Europe. He got it here in the United States. I don't know where he got it from.
Okay, what does TDS stand for?
So T is temperature.
J. Willard Gibbs? Gibbs, is that what you said?
J. Willard Gibbs. Or is it Willard J. Gibbs? I forget. Willard J. Gibbs. Sorry.
This reminds me of Ben Gibbs.
Is that
And
TDS
that's
or
probably not
T?
T delta S. So delta G is equal to delta H minus T delta S.
Outside.
Yeah, that looks like a D.
What looks like a D?
That is
Delta
not a
delta
triangle.
in front of the S.
I don't know how that looks like a D. But
But
anyhow,
definitely.
So-
Red rounded corners.
if delta G is negative, the reaction will occur spontaneously.
What do you
In other words, the reaction will occur.
like when you say spontaneously?
You just mix the two things together, they will react.
Well, like I thought spontaneous meant like if you don't you mean like instantly?
No. I mean, if you mix the two things together, they will react. That's what we mean by spontaneous. And I find it kind of ironic that this whole course is called chemistry, yet it's not until the very, very end that we teach you how to predict whether two things will react. How do I know if barium oxide will react with sulfite? Maybe you mix the two things together and nothing happens. You gotta find the delta G. If the delta G is negative, those two things will react. Okay? That goes for anything. If you want to find out if sodium chloride reacts with tin chromide, calculate the delta G. If it's negative, they'll react. If it's positive, they won't react. Will strontium oxide react with bromine gas? Calculate the delta G. If it's negative, they'll react. If it's positive, they won't.
Bigger the number, the more will it react?
No. See, here's the thing. Delta G tells us whether or not they'll react. It does not tell us how fast it reacts. So, just like with that thermite reaction, you could have a reaction that goes very, 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 very slowly. So, delta G does not tell us how fast or how vigorous. That's a different branch of chemistry called kinetics. Delta G is positive. The reaction will not occur spontaneously.
Mr. Strauss,
Yep.
if it doesn't tell us how fast it will go, how can you like assume that it's spontaneous?
Assume that it's what?
Spontaneous.
Well, because we can actually measure it and watch the reaction, so we know the reaction is occurring. Some of them may just occur slowly. Some reactions occur very quickly. So let's calculate the delta G for this reaction. Two things to be aware of when you're calculating delta G. That delta H is in kilojoules, delta S is in joules. So for delta G, you've got delta H, which is negative 470 kilojoules per mole. Subtract the temperature times delta S. And what temperature are we at?
That's 0.
What does this little
20.
symbol mean?
20.
So not 20,
25.
it means 25.
Degrees Celsius.
So 25 degrees Celsius and 1 atmosphere is called standard conditions. That's what the little degree symbol means, standard conditions. Do not confuse that with 0 degrees Celsius and 1 atmosphere. That
Maybe 1
is
kilopascal?
STP, or 101.325 kilopascals.
Oh, okay.
We could change it to Kelvin.
We will have to change it to Kelvin. So 25 degrees Celsius is the same thing as 298 Kelvin. And then we're going to multiply it by our delta S, which is 11 joules.
Would that be a-
There are 1,000 joules in a kilojoule. So we're going to shift the decimal point 3 places. And now we calculate the delta G. And it comes out to be negative 467 kilojoules per mole.
Mr. Strauss, that would be kilojoules.
Oh, thank you. So,
Is that a 6 or a G?
that's a 6. That's a G.
They look the same.
So, will this reaction occur, Mr. Miller, or not?
Yeah.
Yes. If delta G is negative, that means the reaction will occur. Barium oxide will react with sulfite. But like I said before, it doesn't tell us how fast, we just know the two will react. It might be a very slow reaction, like paint drying.
I like the exclamation point. It makes it more excited.
Now you can calculate delta G just like you did with delta S and delta H. If you go to Appendix N, you will see a whole bunch of delta G values. delta G for sulfite is negative 455 kilojoules per mole. The delta G for barium sulfate is negative 1362 kilojoules per mole.
Wait, SO3? No, I think, oh,
The
Am I-
delta S for is 561, I believe. This one's not in your book. Just make sure I got that number right.
yeah, Mr. Strauss, SO3, shouldn't that be, negative 374?
Oh, yep, should be 374, sorry. I looked at the wrong one. No, 521, sorry. So you look these up on your delta G column, and you can calculate the delta G of the reaction the same way with products minus reactants. So a product minus and that's what we get. And now, why is it called the Gibbs free energy? Okay, this is the energy that is free to do work, free or available to do work. When I mean work, I mean make a car go, make an engine, airplane engine fly, roll a beer barrel up a ramp, okay? It's the energy that you have to go do something with it. When we calculated delta H was negative 470 kilojoules per mole. For some reason it doesn't work for me. So when we calculate the amount of heat released, it's negative 470. When we calculate the amount of energy that we can use to do work, it's 3 kilojoules less. Okay? What happened to that 3 kilojoules of energy? The way you want to think of it is that 3 kilojoules of energy here was used to reorder my molecules around. Okay? The delta S was negative. It was a negative 11, which means I was going from disorder to order. You can go from disorder to order, but you must use up some of your heat. And therefore, what we get out is less than 470. We have to use some of our energy to go from disorder to order. Okay? It is impossible to go from disorder to order without using energy. Okay? Your room wants to go to disorder. Okay, you want to go from an orderly room to a messy room. Can you take your room back to a nice orderly state? Yes, but you must expend energy to do it.
And it's unfavorable.
And that is not favorable. So you will have to use up some of your energy in order to go back to that ordered state. Okay? So another way you can think about this, again, Nadia, is I think of dollars, okay? If you have $1,000, you take it to the bank, you put it into the bank account. And then you check your statement, and it says that you have $950. And you're like, what the heck? I gave you $1,000, why is there only $950 in there? Because it cost you $50 to open up the checking account, okay? So the $950 is the amount you have free to spend. So I had 470 kilojoules of energy, but I had to spend 3 of them to go from my disorder to order. So this is what I have left over. You can think of it, delta G as the what you have left over. This is what you can use then to go spend and do work. That's why it's called the Gibbs free energy. It's the energy that's free or available to go do something. So whether you calculate it like this or like this, it doesn't matter, whichever one you like. For homework tonight, we have numbers 11 and 12 on page 698.
It's a 12 and 13.
Oh, does it say 12 and 13 over there? Okay, 12 and 13, sorry. 12 and 13 on page 698, and then 14 through 17 on page 702. Okay, so we have 6 problems tonight. They're all doing the sort of stuff that we've done. Any questions before we start going over the test?
Want to review?
Yep.
I think we had a couple of these on our review that we didn't want to do.
Yeah, I told you not to do those.
Uh,
It was like number 38.
yeah, it was like A, B, C, D, whatever.
I think it was just A and B, but.
Yeah, we had to do that last time.
Okay, so let's take a look at your tests. We'll start going through it. So number 1,